Hi, welcome back. Today we're going to talk about functions of multiple variables. So we're leaving the world of vector functions and we're talking about a different type of function this time. I always find it useful for us to go back to think about the functions of one variable that we're most comfortable with. Those are those functions that are a function from a subset of the real numbers into the real numbers, right? F takes x and gives out a function f of x. This f takes in the input is a real number, and the output is also a real number. And so in terms of these definitions that we're used to thinking about, we have the domain of f are the x values where f is defined, while the range of f are the y values that f can output. Right? There's some y value, there's some x that gives that y value when you plug it into the function. So what we're going to talk about now, we're going to talk about functions of several variables. And so those might look like this, a function from R2 into R. But we're also going to talk about the case and think a little bit about the case when we're talking about a function from Rn to R. Right? What does that look like? Well, that looks like taking in a coordinate pair, a set of x and a y, and the output is going to be some function of x and y, which often we'll write as z. So you take in two numbers, x and y, and you output a number z, a real number z. That is the function value of x and y. So the input here are two real numbers, or n real numbers, x and y, and the output is a real number. Z is equal to the function value that you get when you plug in both x and y. So in terms of domain and range, right, the domain is the same idea of what are the inputs that you can put into this function. So in this case, it's going to be a set, or we can maybe think of this as a region of xy pairs where f is defined, and then the range is the set of z values that can come out. So the z values that f can output. All right, so we're now going to be focusing on these functions and the other things that we can learn. And so we are going to be trying to understand these functions in a couple of different ways. So here's a couple of different ways in which we'll develop our intuition about how these functions work and what we can learn about them. So we can ask the question, what is the domain of f? So what's the domain of our function? And like we said, this is going to be a set or a region of points. We can sketch the graph of f. And when we, in the past, when we've drawn a function and we've drawn the graph of that function, that's a line or a curve. into space. But in this case, when we sketch the graph of f, that's going to be a surface that's over the set where it's defined. A surface over the domain set. All right, and then the last thing that we'll do, so we'll learn how to sketch the graph, and we'll also develop our computer tools to be able to do that ourselves. And then we can talk about drawing the levels curves of the function. And so what these represent, these are curves in the domain that give the same function value at all of its along the curve. Okay, and so we're going to go through and talk about those three different things. All right, so let's first talk about the domain of a function. What might that look like? All right, so let's say we have a function f of xy is equal to the square root of x plus y plus 1 divided by x minus 1. So if you look at this function, right, we plug in some values, an x and y value, and we get out some value, some number. So for example, let's say we looked at what is f of 2 comma 1. Well, we plug in the 2 where the x's are, 2, we have a 2 down here, and we plug in the 1 where the y is. And then what do we get? So we square root of 4 over 1, so this gives us 2. So this is a function, it takes in two numbers, and based on what those numbers are, it gives out the final value, which is a number. Right? Before we were plugging in a time and we were getting out a vector. For these functions, we plug in multiple numbers. You can maybe think of it as a vector if you wanted to. We plug in multiple numbers, and out comes a number as the answer. So when we want to know about the domain, we have to say, well, what is going to make sense to plug into this function? So to plug into this function, well, we need to plug in, we have to say, in order for this to make sense, we need that the thing that's inside the square root, x plus y plus 1, has to be greater than or equal to 0. And we need that the denominator is not 0. And x minus 1 is not equal to 0. So those two things together are going to tell us what's allowed. And so in terms of visually, what we would see is we would see, oh, that's saying that y is greater than or equal to negative x minus 1, and x is not equal to 1. So if we wanted to graph this set, we could say, all right, let's draw the function negative x minus 1. Y is bigger than that. But we also have the case that x cannot be equal to 1. So what does that look like? X equals 1 is this line. So the set of all points, I'm going to kind of erase that and then redraw it. So the domain of this function is going to be the set of all points that are in this region, this shaded region, that are not on this line. Okay, you're starting to see already that the domain of a function can be a lot more complicated. The domain of a multivariable function of multiple variables, can be much more complicated than what we're used to. Before, domains are always intervals, but here these sets can be a little bit crazier. Let's do one more example. G of xy is equal to x ln of y squared minus x. So here we're multiplying two things together. That's allowed. But in terms of an ln function, a natural log function, what we'll need is we'll need that. So in order for this to make sense, we'll need y squared minus x to be greater than 0. So y squared minus x is greater than 0. That's the same thing as x is less than y squared. So if we're going to draw that, then we have to draw x is equal to y squared, which is this curve. And then we need x to be less than that. So the domain here is this region that looks like somebody took a bite out of it. And again, it's much more complicated than these regions that we're used to dealing with for single variable functions. Let's stop there for now and see you shortly.